Okay, so you've done it. You built a RAG system, it pulls from your documents and answers questions, and that first demo, it was a smash hit. But now you've got to make it work for real. Let's get into it. Because that jump from a cool prototype to a rock-solid enterprise product, well, that's a huge gap where a ton of projects just fall apart. You know, this quote from the source material just absolutely nails it. Your prototype is that perfect, shiny model car sitting in a lab. It proves the concept and it looks amazing. But a real product, that has to survive the highway. It has to handle traffic, bad weather, all the chaos of the real world, and still get you where you need to go safely every single time. And right here is where that difference becomes so clear. A prototype, hey, it can crash. No big deal. An enterprise product has to be up and running 24/7. A prototype is basically a black box. A real product needs full-blown monitoring so you know exactly what's going on inside. You're making the leap from a little tool built for just one developer to a massive system that can handle tons of users with really tight security. That right there is the productionization chasm. So if we're going to build a bridge across that chasm, we first have to really understand the weak spots in our foundation. Let's pop the hood on the typical model cars we build at the start and see exactly why they aren't ready for the highway. And it really doesn't matter how you got started. Maybe you coded your RAG system by hand. That's the handicraft model. It works, but it's a total black box. Or maybe you used a cool low-code platform, the showroom model, which looks awesome, but you can't really customize it deep down. Or you're running a model on your own machine, the Island engine. You've got all this power, but you don't have a car built around it. Every single one of these gets you off the starting line, but not one of them is ready for prime time out of the box. So how do we start building that highway-ready vehicle? Well, it all starts with the fuel you put in the tank. The first, and maybe the most important, pillar of an enterprise-grade system has almost nothing to do with the fancy AI model. It has everything to do with the data you feed it. This is like the unbreakable law of enterprise AI. Seriously, you could have the most powerful model on the planet, but if you feed it messy, irrelevant, or just plain old information, you are guaranteed to get garbage out. It's that simple. Your system's potential isn't capped by your algorithm, it's capped by the quality of your data, period. And this number, wow, this really puts it all into perspective. The source material estimates that a full 70% of a knowledge base's success comes down to data governance. The not-so-glamorous work of cleaning, organizing, and managing the data. The actual algorithms and models, that's just the other 30%. We all obsess over the model, but the real work, the thing that makes or breaks the project, is right there in the data. And look, this is not about uploading a folder of PDFs one time and calling it a day. Building a real enterprise knowledge base is a continuous life cycle. It is a living, breathing system. You go from planning and cleaning all the way to deployment, but the crucial part is that it always loops back to optimization. You have to constantly be maintaining it, updating it, and making it better based on how people are actually using it. Okay, so our fuel, our data is clean, it's reliable, awesome. Now it's time to upgrade the engine itself. Let's take a look at how we transform that simple little motor from our prototype into a high-performance, enterprise-ready powerhouse. This probably looks pretty familiar, right? This is the basic RAG system that most of us build at first. It's a straight line. A user asks something, we search for some documents, we stuff them into the model, and we get an answer. It works, for sure, but it's also pretty fragile. Now, look at this. Compare that simple flow to a real enterprise architecture. This is our highway-ready engine. We've bolted on these crucial new modules to handle how messy the real world is. We're talking about things like hybrid search that uses both keyword and semantic search, and a re-ranker that takes the first batch of results and figures out which ones are actually the best. All of a sudden, our simple little line has become this sophisticated, multi-stage pipeline that's built for one thing: accuracy. And building that pipeline leads to this fundamental shift in how you have to think. We have to move past just fiddling with the final prompt, which is prompt engineering, and instead, we need to get obsessed with meticulously crafting the information the model gets to see in the first place. That is context engineering. And trust me on this, controlling what the model is fed is way more powerful than trying to control what it says. All right, so we've got clean data and a powerful engine, but how do we actually know if our car is fast or safe or efficient? This third pillar is all about measurement, about proving that the system we've built is actually any good. This is the question we really have to ask ourselves, and we have to be honest about it. Not just, hey, does it work sometimes, but is it consistently accurate? Is it relevant? Is it trustworthy? Because if we don't have a way to measure this stuff, any changes we make are just shots in the dark. So to answer that, we need a framework. And the RAG evaluation triad gives us a great one. First up, context relevance. Did our search even pull up the right documents to begin with? Second, faithfulness. Did the AI stick to the facts in those documents, or did it just start making things up? And third, answer relevance. Did the final response actually, answer the user's original question? Now, obviously, checking thousands of these responses by hand is just impossible. And that's where this really cool technique, LLM as a judge, comes into play. We can actually use a super powerful model like GPT-4, give it our scoring rules, and have it automatically grade how well our own system is doing. This is what makes it possible to evaluate our system at scale, all the time. And finally, we need to install the safety features. This is the nuts and bolts engineering that keeps our car on the road. It's about building in the resilience to handle all the bumps and failures that are going to happen in a live environment. It's not a matter of if, but when. This right here is just a classic engineering playbook for making things not break. Think of it like a series of defenses. First, you use retries for little temporary network glitches. But if a service keeps failing, a circuit breaker trips, which stops you from hammering a broken service and causing a bigger mess. And if everything just completely fails, a fallback gives the user a nice default response so things degrade gracefully instead of just blowing up. So let's just pull it all together and look at this transformation. We started with this single, clunky architecture. Now we have flexible microservices. Our retrieval went from a simple vector search to a smart hybrid system. We've gone from just manually checking a few answers to having automated metrics for everything. And we went from having zero resilience to having a system with real built-in fault tolerance. We have officially bridged the chasm. And that all leads us to the final critical question you need to ask about your own project. Is your AI a beautiful lab experiment, a hand-polished model car? Or have you done the hard engineering work to build a vehicle that is truly ready for the highway? Because at the end of the day, that is the difference between a demo that's just cool and a product that creates real, lasting value.